Why are we talking about ActivityPub and end-to-end encryption? We should be talking about this, or I've still got my Doctor Who presentation ready at hand if anyone.
No worries. All right, well, let's kick it off here. Welcome back to the Protocol Symposium. It's a 2-week online showcase of the work from the Summer of Protocols 2024. Today, we are here with Evan and Tom, who will be talking about their project, the end-to-end encryption in ActivityPub. So go ahead and take it away, fellas.
Does that work?
Looks great.
Yeah, perfect.
Looks great. Good. I love this part. Great. So we're gonna try and switch off between me and Tom going through the talk today. We have a lot to talk about. First, talking about the purpose of our research. Tom will talk a little bit about our user stories, design research. I'll get into some of the potential architectures for the solution, and then come down to an explanation of the solution that we landed on. Tom's going to talk about some of the UI guidelines necessary for handling this kind of issue in a federated social network. And then I'm going to talk about our next steps, what we do next from here. So what are we doing when we talk about E2E over ActivityPub? What does that mean? ActivityPub is the distributed social network API and protocol. It was standardized by the W3C, the World Wide Web Consortium, in 2019. It's got its roots in RSS, feed formats, being able to follow different kinds of blogs or publications. But it has a number of interesting changes that make it much more social. So structurally, it defines a number of JSON-based types and formats that represent objects in a social world: people, applications, organizations. Also the connections we have in a social world, what our social graph is, the kinds of activities that we do in a social world, liking things, sharing things, replying to people. The one nice thing about ActivityPub that makes it more interesting than feed formats is that it's push-based. So as soon as someone you follow updates, does something, that gets pushed to all their followers. So it's got a real-time aspect to it. Another wonderful part about it is that it's very extensible. We built it so that, I was one of the standardizers of this. It was built to be much more extensible than older feed formats. So I've got a beautiful UML diagram here for those of you who like writing software. Basically, the rough way it works is that each user connects to their own ActivityPub server and sends messages directly there. And then servers make sure to interchange messages that are destined for users on other servers. So this is a very familiar topology if you're used to, say, internet email, where we use mail servers, send your message to the mail server, and the mail server routes it to the right people. We're doing the exact same thing here with ActivityPub. By the numbers, there are about 30,000 ActivityPub servers live on the internet today. We know of about 20 million registered users who are using these applications. And there's some dark matter out there, people who haven't been well measured. We think that there's somewhere around 2 million measurable monthly active users. There's probably a lot more. In terms of implementations, we've got a lot of big companies and big organizations who use it: Flipboard, WordPress, Meta for their Threads product. Mastodon is probably the best known, and people often call the network the Mastodon network, even though it's a lot more than Mastodon. Ghost is another big implementation. One thing that is different between the way that ActivityPub was designed and the way that it's actually worked out, it was designed to be much more like email and have operators of servers have a high trust relationship with those users. So just like your company sets up an email server that you can send mail through, and you trust your company not to go through your mail, or you trust a paid cloud service, not to go through your mail unless it's absolutely necessary, we expected to have a network of servers provided by these high trust server networks. What actually has shaken out on the Fediverse is a lot of these servers are run by anonymous or pseudonymous hobbyists, and they are free software activists or people from vulnerable communities who have set up these servers. And another thing that has been very attractive here is that there's a high risk user base. So there's a lot of LGBTQ people who have looked for privacy on the social web, avoiding some of the harassment that they saw in other networks. There's also a lot of political participation and a big info security contingent. So what we've got is a combination of low trust relationship between users and their servers, unexpected, and also a highly vulnerable population of people who are using the network, also not expected. So why is that a big deal? Well, posts on ActivityPub are encrypted in flight. So as they go through the internet, they go over SSL, HTTPS. Users have a lot of control of privacy on their posts, who's able to see them. But once they get to a server, they're stored in the clear, meaning that the server operator is actually able to go see them directly. And because these server operators have little or no relationship with the users, there's not great trust there. And even if you have strong trust in your own server, you may not have trust in your correspondent server. So users really don't trust the privacy of this network. And you see, like, Mastodon has a big banner that says, like, do not share sensitive information on Mastodon. There's no end-to-end encryption. So what we came here to do is solve this problem by integrating end-to-end encryption into ActivityPub. So that's the point of this research project. Our two deliverables from this research project: the first is a proposed protocol for E2EE over ActivityPub for W3C. And the second is a reference implementation, designs, architectures, et cetera, and probably some proof of concept work too. And now I'm going to move over to Tom. Tom, I'll just do slides for you. So just tell me when to advance.
That would be great. There's a run of slides in a moment with we're going through fairly quickly. So I'll just say
I've got
next.
my tapping finger ready. Yeah, we can
Brilliant.
go.
Thank you. Next. Thank you. Okay, so the first thing we did when we sat down to do this project was we spent roughly the first month to 6 weeks like delving deep and trying to just understand the space. Obviously, Evan is an expert in ActivityPub, technology director, protocol expert in the area. So he went off and started digging into the various encryption approaches and trying to work out a first pass of what would work best with ActivityPub. And he went and talked to the communities to determine their goals. We'll talk a bit more about that in a minute. That's his next section. In the meantime, I'm more of the design and product side. So my role here was to work out how other people are articulating or building or creating products around end-to-end encryption, to get a sense of how it works, get a sense of what's new or different or complicated about it, and the kind of flows and stuff involved in it. What with the goal that eventually we'd come back together and reunite and say, this protocol works best and the way it operates will be compatible with a good user-centered design flow. So I was looking at flow of data. So I went off and dug into a whole range of other clients and products. And the goal for me was, what's the flow of data? How's stuff moving around, keys and all that kind of stuff? How do they communicate to users what's happening, if they communicate to users what's happening? And what additional features or screens do these apps have above and beyond non-end-to-end encrypted messaging? Because obviously ActivityPub as a protocol has messaging as a core part of its functionality already, and many clients out there already support it. So if we go to next. Next, please. Yeah, so we're just going to cycle through these every five seconds. Basically, I went through and I looked at all the core screens and all the core flows for Facebook Messenger, iMessage, next, WhatsApp, next, Signal, next, Telegram, next. Viber, next. Threema, next. Wire, next. Wicker, next. Element, next. Keybase, next. Line, and I think that's it. One more next. Brilliant. So what you'll have noticed from that is there's a fairly steep drop off in terms of the names you'll have remembered or recognized. But you'll also have noticed, presumably, that a bunch of the sort of core services that you use every day, including WhatsApp, iMessage, and Facebook Messenger, all have inbuilt end-to-end encryption. It's just normal, and you don't notice it most of the time. It is, they don't advertise it particularly. It's not like highly promoted. Most of them don't spend a lot of time doing a sort of security theater around it. The assumption they've got is that this is just a core piece of the functionality you should have, and they're going to provide it. Now, the full document where I went through all of these things, which was looking at exactly like what's the setup process, how did they work, what's the interaction design of the messages themselves, how much do they talk about encryption. The full document is at that URL at the bottom of the page, and it has like pretty much everything for these sort of 10, 12 services. One thing that was interesting again is like there's a fairly quick path of diminishing returns in this one. Like once you're put past the top 5 or 6, you've seen most of the patterns that most people build with. So let's go to the next one. There were 3 major conclusions that this work came to for me. The first one is that messaging UIs are wildly standardized at this point. I'm doing this document which goes through pretty much everything that in the space, to sort of talk about things. But one thing that became really clear is I probably don't need to do too much work articulating what a messaging UI looks like on mobile. It has 2 views. One is here, a list view, where you can see the conversations in place with the most recent one at the top. Maybe you can swipe on it for more interactions. Maybe the new button's in a slightly different place, but it's pretty damn standard. Next. And that's true of all of them. Like that's true of the individual conversation slides as well. It's true of the way it's represented on the web as well. The other thing that became really clear from looking at the sort of I hate to call them competitors because they're not, but like the other things in the world that use this kind of stuff is they've all pretty much standardized technically as well around public key encryption models, mostly based around the signal approach. Now, some of the conversation we're going to have in a minute involves people having a basic understanding of what public key encryption means in this space. This is a massively bastardized description of it. Please don't think, that I'm too stupid to have got this right. This is just the things you need to know to progress. So when you sign in onto a client, any new client you have for your thing, that client creates a public-private key pair. It puts the public key on the central server that's there to be discoverable, and the private key never leaves your client. When someone writes you a message, they go to that server, they find your public key, they encrypt their message multiple times, one for each of the public keys you have stored in there, and also to themselves. They encrypt it based on their own keys so it can go to their own clients if they've got more than one client, and then it sends it. Each of your clients then receives a message that only that client can read using their locally stored private key. And since no intermediary service, it's your private key, never leaves your device, the messages are secure. No one in the middle can read them. That's basically how it works. And pretty much all of these things operate along that level. And if we get the next one. And the last bit is the sort of UI challenges aren't in the chat itself. And there are 3 areas in particular I want to draw people's attention to, particularly if you're upgrading from a non-E2EE approach to one that includes end-to-end encryption. The first one is you need to have a set of features around key management. When someone adds a new client, they need if a new client is added to your account, you need to be informed to make sure it's you and that someone hasn't got hold of something or logged in without your knowledge. And you as a user, if you lose your phone, need to be able to go and revoke the key associated with it. Another thing that's really distinct and interesting is how archives work. And I'm going to talk a bit more about that later. But the short gist is because a client can only read messages that have been explicitly sent to its public key, if it only just got a public key, none of your archived client messages are readable. None of them. So you have to find a different way to restore your archive from somewhere else. And then the third bit that became interesting and confusing was about having both E2E messages and non-E2E messages in the same environment. And obviously this is because Mastodon and ActivityPub based products already have direct messaging and private messaging built into them. So, but they are not encrypted. So the question about how to have those two things operating in the same space without them colliding or causing more confusion or problems is like one of the larger problems. Next. So once I'd gone through that process of investigating all this kind of stuff, and Evan was out there doing another set of work, investigating the protocol side, we both independently came together, well, both independently wrote up what we considered to be the sort of user stories for our bit, what this product needed, what this protocol needed to be able to serve. Evan's are, as you'd expect, engineering focused, mine are, and protocol focused, mine are user interface and user focused. So so the big job that we did at the Edge Esmeralda event in Healdsburg earlier this year was make sure that we were on the same page with all of these and understand how all the keys and the messages would be traced through the system. And at that point, I think I'm turning over back to Evan. You're muted, I think.
Yeah, so I'd like to talk a little bit about integration models. So how are we going to put E2E onto this other protocol? One of the things that happened as soon as we announced that we were doing this work is we started getting input messages from people in the community along the lines of, why don't you just X? Why don't you just do this one particular way? So part of the work here was evaluating each of those ways of doing things and making sure that, you know, we weren't overlooking something that was that might be a better way for doing things. So the current state and kind of the kind of one option is like not having any integration, and that's something that a lot of folks said, like, you know, putting any integration in like this, there are other products that do it. Why are you going to bother doing it? Just leave it off. It's definitely one option. Oh, I'm going to run through all these models here. So that's one option, is that we don't bother. I think that we would have spent the summer twiddling our thumbs, not how we were going to engage our time at Summer of Protocols, but it also really does not. It leaves we don't think that the current state of affairs is sufficient. Another option would be just including some sort of structured link to an existing application. So on my ActivityPub profile, I have a link to my Signal account, and you can click it and it starts Signal, and there you go. That's enough. Although that's really low effort, it is also depending a lot on external systems. It doesn't give a lot of shared authentication between the messaging system and the rest of your social experience. And there's a lot of like trust issues between the identities. So big chance of mismatch. So another option is, instead of just like bouncing out to through a link to another app, that there's actually an initiation process that happens within the ActivityPub client or server to start a Signal conversation or start a WhatsApp conversation, and then you move smoothly into that. So you're not popping into another app, you're actually like integrating in. This is an interesting one. It requires you know, some effort from developers, less effort from system administrators. The big problem is like making those two edges work really well together so that you have a smooth experience, because if it's a bumpy experience, it's not much better than just having a link. Not last option. Another option that we definitely heard from quite a bit was like, there are other end-to-end encrypted messaging systems. So XMPP is a messaging system. Matrix is another messaging system. So the idea would be like, you take an entire ActivityPub server, you take an entire Matrix server, you kind of mash them together or overlap them, and they become this kind of unified structure. Again, there's like impedance mismatch between the user structures, the way those two systems work, the way that authorization and authentication work. We felt like it was, it didn't make as much sense, probably going to introduce quite a few quite a few problems. So is there a way for us to build a system that works like an extension on top of ActivityPub, seamlessly integrate? One option is to use a custom API, one of the APIs that was built for social software. Mastodon has an API that's very popular. A lot of Mastodon clients exist. So that's one way for us to do this project. The problem is the Mastodon API is not extensible by either clients or servers. It's got a very fixed format. And we didn't really have any entry points into making changes to that API. So it doesn't support arbitrary data types, which we would need for encrypted content. So it felt like it would be introducing a lot of ugly line noise in for non-E2E clients without actually helping a lot for end-to-end encrypted systems. So given those boundaries, we decided to lean into using ActivityPub as a substrate and building an abstract protocol on top of ActivityPub. ActivityPub has an API. It's very extensible. You can use different kinds of content. I mentioned social content in its JSON encoded form. You can add new vocabularies of content, and with those new vocabularies, make totally different social applications. And the distribution still happens client to server, server to server. So it happens over the same network, but you've got new different payloads that work that way. So given those different kinds of integration models, you know, from having none, which isn't really doing anything, having a full-on integration with some other protocol, we decided that the right way to go was with an abstract protocol that works on top of the ActivityPub substrate. So which abstract protocol to choose? We considered, well, we had one strong candidate when we started, and we tried to open up to a number of different candidates given that. Again, a lot of incoming suggestions that were along the lines of, why don't you just X, suggesting different kinds of abstract protocols that could work on top of the ActivityPub protocol. And I'll talk about a few of them here. PGP MIME is kind of the granddaddy of E2E messaging. It's how people used to do encrypted emails. It's a very simple, well, simple topology, at least. The math for the encryption is still plenty hard. But in terms of the structure, it's very straightforward. There's lots of libraries out there, so developers would be able to engage with it pretty quickly and would probably have a very simple topology. The problem is that as you start increasing the number of addressed people in your messages, you go from one-on-one messages to 1 to 10 messages, and start getting into, say, Telegram-sized group messages. This system just wouldn't scale, right? It barely scales to like 10, and as you get out to like 100, it simply doesn't work. It also doesn't have a lot of robustness in terms of losing your keys. Key management is something that people are used to thinking of as very manual, although we think that it could work in an automated way. SMIME is another similar one, similar structure. It actually has a certificate authority mechanism. So you have these kind of like centralized authorities. It's still very simple, but very old too. OTR, off the record, was developed in the 2000s specifically to bring those structures that were working for email to instant messaging. It's pretty simple. It's a nice, you know, kind of in-between system, and it handles some of the interesting cases like verification of end-to-end encryption, being able to deal with lost keys. Somewhat more complex, not as what, but the big problem here is it's not widely implemented. And it's not great for doing group messaging. So that brings us to modern end-to-end encryption protocols. The 800-pound gorilla for end-to-end encryption protocols today is Signal. Signal has its own client, the Signal client, very popular. But Signal's protocol has been licensed by a number of different implementers around the world. So WhatsApp, Facebook Messenger, Google's RCS system uses Signal. So there's quite a few licensed applications of this Signal protocol. What's cool about Signal is it's very well trusted. It's very robust in terms of security. It is also would give us the opportunity to bridge to other networks. So we could bridge between WhatsApp and ActivityPub and keep the messages encrypted as they go across that boundary, which is really interesting in terms of growing out this system. The Digital Markets Act in Europe has kind of pushed these big messaging systems to open up for bridging. So that might be an opportunity for us here to have a much bigger environment using it. The big downsides with Signal, the reference implementation is GPLv3. This is a very restrictive open source license. It's also a complex protocol. And they're very defensive about the trademark. Trademark is one of the things that they license to these big companies. Signal's run by a small nonprofit, and they make most of their money from licensing this trademark. So they're very concerned about misuse of the trademark. So it brings me to my last candidate protocol, which is MLS, or Messaging Layer Security. This is a IETF standard, so it's an open standard protocol. And it is designed specifically to meet our scenario. So taking a secure messaging layer and putting it on top of another protocol. It was designed for this need. They took some of the designs from other messaging structures and made it possible to scale groups to millions of users. Now, we're not sure that that's a necessity, but it's good to know that we're not going to hit an upper boundary earlier than other end-to-end encrypted systems. The other thing is it's a royalty-free standard. It was standardized at IETF, so we have no problems with intellectual property, et cetera. The cons are that it's really complex. It's very chatty. Clients are like sharing keys all the time and making updates to structures all the time. I say here it's not yet implemented in a major messaging service. It's actually implemented in WebEx now, which is cool. And there's some other systems that are starting to look at it for MLS. Another thing is that for Digital Markets Act, which I talked about previously, at least Meta has said that they would interact with, they would be willing to bridge with MLS-based systems. So it's possible for us to have a system that bridges from MLS. So considering different abstract protocols, one of the things that was pretty surprising here was the social layer really drove a lot of this decision. It was less about technically which is best. In particular, any community discussion about PGP or SMIME went right into the ground almost immediately. It was just considered too old, and because it was old, considered to be insecure and inappropriate. OTR is somewhat obscure, and we just couldn't get work around it. Ultimately, the need for the Signal company to keep control of the Signal trademark just made it inappropriate to try to integrate it over their objection into an open standard, right? It was just too hard to do. So MLS turns out to be the best option for us. So our work then became building an ActivityPub extension, an extension to our protocol that implements messaging layer security. ActivityPub has like certain levers. Here's my more UML, certain things that you can do. Primarily, it's about defining properties of objects on the network, and then different types of messages that can be interchanged between those objects. So that's really the two levers that we can drive for ActivityPub. What MLS needs is actually defined this way into the spec needs two major services, needs one service to do delivery of messages as they're generated, and another one to do authentication, being able to say, this user has this, this key. So we can bring those two together by defining new properties for ActivityPub in an ActivityPub extension. So not required, it's a new experimental mechanism, but implementers can actually use it. The first thing that we defined was a key store. This is something that'll be included with every user account, and it provides that authentication service and stores all the public keys for that user. It's world readable, so remote users can read it, the local user can read it, and it's managed using some standard mechanisms within ActivityPub. And there are potential fallbacks to go to other data stores that are available for every ActivityPub server. I don't know if they're really that compelling because they take a lot of time and a lot of effort. I don't think if a server doesn't support this structure, it's probably not worthwhile to try and do a fallback. Second thing that we are defining in this extension is a groups mechanism. So these are the conversation groups that you're a member of. It's listed. It's a collection of those that you can get from your server, one for each messaging group, only readable by the actor. That's not available to everybody, only by you, but it's got the full set of MLS messages that have happened in those conversations. So as you go into a conversation, you sync up with the MLS messages. There are a few activity types that we're going to have to add. MLS has a few for managing these like big sets of keys that define a group. But we can also reuse messages that are pretty standard out of ActivityPub, which is nice for some of these other things. The big thing, the kind of explosive area for us in this definition is that MLS has, like 20 plus data types that are defined in the standard. And so we need to have those same data types available within this ActivityPub extension. The good thing is that they're very well defined, and translating them into a JSON format, which is what we use for delivery over the wire for ActivityPub, is not that difficult. So it's basically just mapping the definition into JSON. So I guess the question probably seems like, wow, that doesn't seem like a lot of work, right? That doesn't seem like a lot that you're doing. Well, MLS defines a lot of behavior at the client side, and we are just mapping the interaction between that ActivityPub-based client, or excuse me, that MLS-based client and the ActivityPub network. The protocol as such depends on those two existing protocols in order to execute that end-to-end encryption. We don't need to define the full working mechanism of MLS. MLS is already well specified. So it's really about providing that glue layer between the two of them. So that's the good part about this, is that we can have a relatively simple structure with guidance. The hard part is when we actually come up with our reference implementation. So the protocol standard is not too tough. It's the messaging UI and that reference implementation that starts to become a challenge. Tom, you want to take it away?
Yes, brilliant. If you could click forward. So again, like what I wanted to do in this thing, originally the plan was, I mean, I'm doing it, I'm wrapping up the designs now for like the reference implementation, a simple reference implementation. But originally when I started working on this, I thought, okay, I will just do the design work to work through every element of a messaging app end to end and say, here is an example of how to do this right. But as I said, like one of the first things that became very clear when looking at sort of 15 different messaging apps is how bloody similar they all are. Like they really, the standards they've really, really massively standardized. So as I said, this is a fairly normal mobile list view. There's a list of things. The message at the top is emboldened. Maybe you can swipe on it to get some additional functionality. That additional functionality tends to be contextual, but it tends to also not be the only place you can find it. Some people put the new message button in a slightly different place. Some people stick a search bar when you pull down or do a pull to refresh. But these are fairly small interaction design changes. And frankly, if you looked at, as I did, like 15 of these apps after a while, and screen capped them all and detailed them and logged them all at great length, going back to it, I can't tell which is which. If I look at a pile of screens, I'm like, is that iMessage? It really is extremely hard. So if you can click to the next screen, and it's true for all of it. Like the mobile conversation view is basically the same. Like I'm showing you something here, simplified, and I don't think you will. This will not seem like a puzzling UI to you. Every single person will be familiar with it. And if you click again, on the web and desktop, effectively a very similar thing happens. Instead of it being a column, a page that you tap on and then slide into a subview, they put the messages on the left and then the conversation is on the right. And again, there aren't really a lot of recommendations to make in these areas if you click again. And so this brings me back to trying to work out what are the areas where we really do need to help people. And these are the three major ones that I want to talk about a bit today. I brought them up earlier in the conversation. They were things that cropped up a lot during this process, and they are key and client management and notifications around that, handling archives and how to restore messages to a new phone or a new device of any kind, and how to handle end-to-end encrypted messages and unencrypted messages being in the same environment. So if we can now go for the next one. So with key management, right? So the entire principle of end-to-end encryption being secure relies on you knowing that you have created X key pairs, one for each of your clients, that the public ones are out in public, and that the private ones haven't left your phone. So there are two scenarios where something like that could be compromised in some way. Like if someone has got access to your account and creates and logs in on a new device, then a new public-private key pair will be generated, and from that point on, they'll receive your messages. And if you lose a device and left it like unlocked or something or open, then there's always possible that someone has access to that one and can read messages. So they're the sort of the two bits of functionality that the two situations you need to be concerned about. So when moving from a system which doesn't have end-to-end encryption to one which does, you need to be able to do two major things: to be notified if a new client is added, to all your other clients receive a message, and for you to be able to see a list of the clients that are associated with your account, and to be able to revoke one if the phone has been lost or stolen or whatever. So new functionality requires new screens. We click forward. Now, this stuff, you'll have seen this all the time, right? This is what all of this shit is. Sorry, I should have sworn. Across all of, this stuff that we all experience on a semi-routine basis, like you're sitting in front of the television, signing into an app on your iPad, and then your phone on the other side that's frantically buzzing to warn you that someone has signed into your iPad and that you need to approve it. It can be a bit infuriating, but the foundation of it is that you are being notified as a new login, that it is important for your security that you know that has happened. And if we can click forward again. And so, and the other side of this is a fairly standard set of screens. Now, this standard set of screens is basically on pretty much every one of the apps I went through earlier. It's some kind of notification on your home screen when someone logs into your account, and then some screen somewhere, whether it's to do with your sessions or your devices or your logins, which shows you a list of the devices you have logged into your account, and then allows you to revoke or delete access. If you're on an iPhone, you can go to your iCloud page, and right on that page, you will see every device associated with your account, including your HomePods and Apple TVs or whatever, and you can revoke access to every single one of them in that place, because every single one of them has like now access to some of your security. And behind the scenes on iMessage, If someone sends you a message, it will come to any of those devices that has a messaging client on it. And it will only be readable by that device. Next screen, please. So the next thing I want to talk about, and I'll be quick, is restoring archives on new devices. And this is surprisingly complicated for a range of reasons. So again, the core premise of the E2E enabled apps is that your content cannot be read, content that has been sent to you cannot be read without the private key that is the partner to the public key it was sent to. So if Evan sends me a message to my public key, I can only ever read that message if I have the private key. That private key is secured on my device. Often, most of the time, in fact, you are not even able to remove your private key from one device and transfer it to another one. In fact, almost always, Signal allows you to merge two private keys and associate them, but that's about it. That means if you buy a new phone, since it won't have had a public key pair associated with it in the past, and since any message cannot therefore have been sent to that public key, if you log in, by default, you will never be able to read any message from your archive. That is how they all work. Every single one of these systems, in its baseline implementation, will not allow you to read messages from other places. So how do you have a backup? Because we all know when you get a new iPhone, you install it and run it, and you have your message archive is magically there. They all have a separate service, distinct from E2E, where you can choose to back up your messages. It is normally a default process that during your setup, you just click through and don't think about. The messages are separately stored and encrypted and put into those places and then recovered at the other end. So, Facebook does it. They have their own secure thing. You can also use Dropbox or iCloud or something for those. Google uses Google Drive. Apple uses iCloud. We click to the next screen. This is the kind of functionality that you probably don't remember seeing, but is there. When you set up Facebook Messenger, it'll say, "Well, you're going to have a chat history." That's exciting. This is where you store it. And on iCloud, messages on iCloud. So this is completely distinct and separate from the end-to-end encryption messaging stuff. It's like a completely different layer that sits alongside it. Click forward. Now, look, this is a thorny area. A lot of people do not think that however good the encryption is on something like iCloud or whatever, that you should be doing a backup of all of your messages to one of these large providers. But what we do know is that large providers generally are much more careful and secure than small providers, and that they are much more liable to legal threats, and that they are very keen to not be sued. So they tend to use well-established best practices to sync the content between their services. They cannot do it, though, without your permission. Problem we have in our environment is that the ActivityPub environment is much more diverse, and any individual user may have 5, 10 different clients that they're using. And the question, how can I store all my content in a backupable way so that I can restore it later and it's accessible to any client that I might have, is very complicated, right?
Tom, I'm sorry to interrupt you. We're running a little late, so I wanted to let you know.
Yes, thank you. So the normal way that these services operate is Apple or Google will create a little enclave that only your app can access, and you can store things in there, and then you can access that data across different situations. Again, the problem is it's not one app we're talking about here. So this is complicated, and we think actually it's probably not solvable by us. This feels like it's a conversation to be had by an app developer figuring it out in that context. Potentially something will emerge in this space, but in the short term, we're going to focus on the messaging and not on archives and backups. Next page. This is the last one. So the last chunk is about this end-to-end encrypted messages and non-end-to-end encrypted messages, to some extent being segregated. The situation is very simple here, right? Like if I send a message that is encrypted to one person, because they have one key or one encrypted key somewhere, and but it's available to all their other clients, then those other clients won't be able to read it. They can then respond in kind or one of those saying, "New phone, who this? I don't understand what's going on. This is confusing." That message is then sent unencrypted, and then if you imagine this at a larger scale with like every user having 5 or 6 clients, a conversation between 20 people, then there are some real UI problems and complexity problems that emerge out of that one. When we first looked at this approach, that was still our preferred approach because it made it unnecessary for us to do any server upgrades. We'd be able to do transmission of information without any of the individual servers having to do lots of extra work. But in the end, this turned out to be an academic conversation. The protocol choice required a lot more complexity, required us to have a defined new message type separate. So now, effectively, what we're saying is you can either send an unencrypted message and it will go to everyone on the other end's phone, or you can send it to an encrypted message and it will only go to clients that can handle encrypted messages. If we can click forward. So the design guidelines here are pretty simple. They are, as much as possible, try and keep the end-to-end encryption messaging UIs distinct from non-encrypted ones, so there isn't confusion. You choose to look at your encrypted messages or your unencrypted messages. You choose to send an encrypted message that will only be received by people who can receive encrypted messages. And the goal here is to go from a transition where initially this starts off as an experimental feature where, depending on who takes it up in the community first, where it's not used as much until there's more critical mass, gradually getting to a place where it runs in parallel and eventually replacing it. Obviously, this depends a lot on the community. The largest number of servers out there or instances out there is run by Mastodon. If Mastodon decided to turn on encrypted messages across all of their platforms, most users would be immediately in this ecosystem pretty quickly. In the meantime, here are some ideas about how to keep them distinct. If you click forward, I'm like 2 minutes away from the end now. So some services treat private mentions differently from how you'd treat most to how you handle messaging. They put them inside your feed as a private mention. So one situation, one approach you could take in that kind of context is to leave that exactly as it is, but then have end-to-end encrypted messages handled separately as a sort of right-hand or top-level menu item, handled more like other services handle DMs. That would mean 2 very distinct bits of functionality operating at the same time without there being collision or confusion. If we go to the next one, another approach is just to say we'll have some kind of tabbed UI or left-hand menu UI where it says messages, and then underneath it says encrypted messages experimental, and the 2 are kept nicely segregated in that space. And the third approach is to mark each message as encrypted or unencrypted. One thing that's been really interesting to both of us, I think when we came into this, we thought there'd be a lot, as I said the phrase earlier, like performative security or security theater, where people would talk a lot about the encryption they were having. Actually, that only seems to happen in a fairly niche number of smaller apps which are really trying to upsell it. Mostly apps do not communicate to you if they're end-to-end encrypted because they just assume all messages should be end-to-end encrypted and all of their messages are. But there is a scenario you can imagine where you keep them distinct as 2 separate sets of conversations here. I can send a conversation with Evan unencrypted or encrypted, and he will receive the encrypted one and read it only on the device that is equipped to read it. So skip forward. That's effectively those are the 3 areas that I'm spending the most time focusing on, but there'll be a larger document available shortly that explains the rest.
So I'm going to talk a little bit about last steps for us. We are bringing protocol-wise draft proposal to the W3C Social CG. There's a special task force just working on end-to-end encryption for ActivityPub that we started. So this is happening now. We're going to be doing architecture and UI design for reference implementation and hopefully some proof of concept code, but probably not a full reference implementation at this point. Next steps after that is to build out that reference implementation, show what can be done. We'd want to do a revised proposal based on those implementation learnings. What did we learn from actually using it? looking for other independent implementations. Best way to test out a protocol is make sure you have independent implementations, finalize a proposal, and have it become a report from the social group at W3C, which gives it that kind of mandate for wider use. Big questions, Tom? Or are we open to big questions from the audience?
I think we're available. This is not mine. This is, I think I pinged you earlier to say, should this section be here? And you didn't reply. So,
all right.
Hey, everyone.
Well, let's just take it as our way of opening up to questions to the audience.
Yep. How's everyone doing? You having a nice day?
Yeah, doing great over here. If you have questions in the audience, please go ahead and raise your hand, and we'll call on you. And Drawn, you have your hand raised.
Hey there. Thank you for doing this research. Very excited about this. You mentioned that MLS is relatively complex. I worry some that might discourage implementers from actually incorporating it. Is there any way that like a subset of MLS could work to smooth along that process? I imagine that could also get prickly. But that's the question. Thanks, y'all.
That's such a super good question, and dealing with complex protocols. So a lot of what makes MLS a good protocol is that it does a lot of, it's very chatty about, oh, there's a new user in the group. Hey, we've been using this shared key for a while, and now we need to turn it over. So let's agree on what new key to use. It's very chatty in that way. I think that there are two different ways that we can approach making that easier for implementers. First way is libraries, right? There are existing libraries that implement MLS. So providing the glue code that connects those libraries with ActivityPub might be a really good way for us to help get that uptake. The other one, like you say, is leaning a little bit into the subsets. There are some optional parts of MLS, not a lot actually. It's only a few little bits, but we could make those parts, leave those parts out of the ActivityPub profile and make that somewhat simpler. So this is something we're really concerned about in terms of implementability versus uptake. And ultimately, we decided that with all the feedback from the community about we really want something modern, something new, here's this MLS thing. Clearly, everybody thinks it's great. We went with it for that reason. Great question. Thank you.
Awesome. Dorian, you have a question?
Hey guys, thanks. That was really comprehensive. So when you showed the MLS, you were saying something about the MLS namespace. Are they implementing their objects in RDF like you guys are doing under the hood and activity streams, or is it just some other thing?
Yeah, so we use JSON-LD, and so it's like an RDF encoding, right? And in order to build extensions to ActivityPub, we have to define a new namespace. So we would be defining this new namespace for this process. I think that in terms of MLS, it has a definitions for all these object types, but they're not namespaced. So we'd be basically taking their object definitions and mapping them into that new namespace.
Right. Is it a sneaky thing like you're doing with activity streams though? Like there's an OWL ontology under the hood and you kind of project that out in a JSON?
Not actually the case. Yeah, we need to do it through standard JSON-LD mechanism. So doing a full JSON-LD context document to make that work. Next question.
Any other questions from the audience?
I haven't had a chance. I don't think Tom and I got a chance to scroll back into the chat. Were there any questions that came up in the chat that folks thought we could address here?
I think there was a long conversation and question about Doctor Who and how much they wanted me to explain what's happened in the last 15 seasons of that. Quite welcome to answer that one, but maybe another time. Anyone else?
Great.
I mean, one thing I would like encourage people, if you have questions about, one of the things that's been really interesting about this project is neither Evan or I are sort of like innate experts in encryption. So we've gone out there and talked to the experts in encryption and applied that to our territory. But I mean, Evan's obviously considerably more expert in that than I am. But the one thing that's been really interesting to me in this space is figuring out like how these things interoperate and work with one another. So if you actually have a question just about like how the existing services work, and why things are the way they are, please ask, because I found that stuff fascinating.
Eric.
Yeah, when you did your very sort of quick run through of the various messaging apps, did you guys come across Session at all? The most privacy oriented folks I've talked to strongly prefer that one for technical reasons that completely outstrip my capability of adjudicating.
I did not come. I don't recall that one. I did quite a lot of extensive searching and investigation and looked at web and a mobile UI. But if I missed that one and it's particularly good, then that reflects poorly upon me.
It did feel so private that no one seems to have heard of it other than the privacy advocates that convinced me to download it onto my phone.
Oh, interesting.
Is it good?
It suffers from the deep challenges of network effects that sort of corrode better improvements in so many technical ecosystems, which is if no one will message me on it, then the benefits are limited to me and the one person who convinced me to install it on my device. So, take that for what it is. And I have zero interest, financial or otherwise, in the app itself, just more it came to mind when I saw your impressive run through.
Fantastic. It was it's such a great one. And I love the fact that Tom went deep into like every single messenger that either of us had ever heard of. And there was still another one that we didn't include. Thanks so much. It's worth taking a look at.
No, absolutely.
I think we're at the close to the hour. So I think you might get the last word.
One thing that's always confused me is how disappearing messages and deleting messages works. Like sometimes you get an option to delete a message for yourself or for everybody. And how does that work and how does it interact with encryption? So both disappearing and deletion.
That's not something we want deep into with the disappearing messages. For deletion, I think that's it really has to do with like buy-in from all sides, right? So you delete a message, it really has to be deleted on all the other systems. I think for most of the messaging systems that are monolithic, that aren't federated like ActivityPub, you can count a lot more on that deletion happening. I think it's probably a fair thing to say that deletion probably is less easy to count on in ActivityPub. So we have a lot of ActivityPub users who make posts, delete messages, go out. They are almost universally approved and taken care of. I don't know of ActivityPub implementations that don't do deletes, but it's at least theoretically possible.
I think that's an interesting one in a range of ways, and it ties into sort of adjacent to the conversation around Telegram at the moment as well, and the very specifically odd way that they handle private conversations, where almost nothing on Telegram is actually encrypted. It's all just stored on their servers, and so the first thing is it stored on their servers? Like if the message is just routed to you and arrives at your end and isn't kept on a server, it's a hell of a lot easier to have sort of automatic deletion at the client layer. The other thing is they also do this thing where you with Telegram in particular, you launch your device, you say you want to have an encrypted message with, say, Venkat. Venkat is informed that I want to have an encrypted message. The server swaps our kind of direct contact details with one another, and then the server is taken out of the picture, and we are from that moment on talking to one another completely directly. It's a very complicated way to do it, because you can't, normally you can't just rely on knowing precisely how to have a direct person-to-person communication with the other player. But yeah, I think Evan's right. Like, one of the core things about all of those services, and one of the real complexities about ActivityPub in this area, is the variety of clients and the shift in it. You cannot rely on the receiving client being, the kind of standard or quality that you're using. There's just no way to do it, so you have to have a conversation in which you're saying, like, I as an individual choose what kind of quality of app that I want to use. The person at the other end makes similar decisions, and this is a sort of social contract that we're assuming these things will operate in an effective way. We obviously, in that environment, we can't say the message should be automatically deleted from the client, because someone will just build an ActivityPub client that says, I'm not going to do that. And there's nothing, once they've received it, they can cache it and it's done.
Do we have time to go to Jiang's question?
I'm happy to, if everyone else is.
Let's do it.
Okay, great. Jiang.
Hi. So you mentioned the MLS protocol is very chatty, and that they overload the ActivityPub providers or server, and we will embed the MLS feed in the user's feed, or is it a separate, and could we implement it in a separate feed so that it doesn't interweave with each other?
Yeah, excellent question. That's exactly the point of that separate groups property on the actor, is that all the MLS messages are going to go directly in there, and they're not part of the main inbox, right? With that idea, they're not overloading the conversations that are happening elsewhere. Really good question. Absolutely the case. Cool. Great. Well, I think we're at the hour. I want to say thanks, Tom. Thanks, everyone. Do we have contact information we want to share, Tom? I guess find us on the Fediverse.
Awesome. Thanks, fellas, for a great talk, and we'll see you all tomorrow for another dive into Summer Protocols 24 research. Yeah, we'll see you tomorrow, and may your beards be ever full.